You're listening to the VSL Aviation Podcast. I'm your host, Seth Lake. Whether you're listening on your favorite podcast platform sometime in the future, or you're watching us live on YouTube or Discord, thanks for joining us. This is our weekly installment where I answer your aviation questions and cover some of the hot topics of the week. Most of these questions come from email on our Discord channel or just me hanging out around a lot of airports and giving a lot of check rides day to day. But if you want to send in your own question, you can get in touch with us on Discord, or you can send an email to me at sethlake@vsl.aero, and I'd be happy to answer it on a future show. If you're familiar with the YouTube videos, I cover a lot of longer form podcasts where we go over the ACS and kind of get you ready for your check ride. We do some of that stuff in this weekly podcast, but this is just meant to keep us updated in between those longer episodes and give me a chance to have more interaction with you, the listeners there. So we are going to get started. Now, if you're joining us on Discord, or if you're not on Discord, you need to join our Discord channel. There's a link in whatever platform you're listening to. There'll be a link to the Discord channel. So just go to the description. You'll see a link and you can join us there. Discord's like a social media type thing, but it's pretty... I don't know, it's a little more private. It's not open to all the stuff that you get on Facebook and Instagram, so kind of exclusive, but it's not behind a paywall or anything. And what I've done is I've got a podcast companion thread on our Discord channel. So everybody that's with us on Discord can check that out. There's a link in our comments section there. Or if you're joining us at a later date, you can go to our main Discord channel, and then there's a 3/25/25. So it's March 25th, 2025. Live stream, and that's where I've basically put in the notes for this week's show of all the stuff that we're going to cover. So if you're joining us on the future, or if you're listening to this in a couple weeks and I cover one of the links that you'd like to know more about, go to our Discord channel and we'll have a detailed list of all the links that I'm going to, all the discussion topics, and then we'll also be able to drop in some comments and kind of interact with this in the future as well. We'll see how it goes. This is the first time doing that. All right. That's enough house cleaning stuff, so let's get started. We are going to talk about 4 different topics today. The first thing I'm going to cover is accidents, NTSB notification, that sort of stuff. Next, we're going to talk about avionics, and then we're going to move on to maintenance and required equipment. I've broken this down into 2 different topics where we're going to talk about first required equipment and just update about the newish advisory circular that's out there. And then we're going to talk about some maintenance manuals, because I don't think I've ever really talked about maintenance manuals, and I think a lot of pilots overlook those. So we're going to talk about those as well. Then I'll open it up for questions for those of you watching on YouTube. You'll be able to type your question out. For those of you that are on Discord, you'll be able to speak on the stage live with me if you want to do that, or you can type your questions out. Okay, let's get started with accidents. So this has come up several different times, and there's maybe some late breaking stuff. There was an accident that I knew about here recently, and the question came up of, is it a reportable event? And so I thought I'd take the opportunity on this platform to talk about, well, when do you have to report an accident? And what is an accident? So I've got my screen shared pulled up here, and this is in the link on Discord if you want to follow along. But we're looking at NTSB 830. So that's the FAR that guides us in when we have to notify or report an accident and what an accident is. So first, it has the definitions section. We'll scroll back to those here in a second. And then subpart B talks about initial notification. And it says, I try not to read a lot of regulations on here, but for those of you listening just on podcast format, I'll go ahead and read through this just a little bit. So immediate notification is in subpart B. And it says, the operator of any civil aircraft or any public aircraft not operated by the armed forces or the United States or anything like government stuff shall immediately and by the most expeditious means available notify the nearest NTSB office when. And then the first option is an aircraft accident or any of the following serious incidents occur. That's option A. Option B is an aircraft is overdue and is believed to have been involved in an accident. So I think where the failure of notification comes in is in this part A, there's looks like 12 subparts. So we got 1 through 12 of the subparts underneath A. So all of those, remember, we have to notify of an aircraft accident. One of the options is flight control system malfunction, in-flight fire, aircraft collision. But it's option 6 that I think messes up a lot of a lot of pilots, and that is damage to property other than the aircraft, estimated to exceed $25,000 for repair, including materials and labor, or fair market value in the event of total loss, whichever is less. Okay, so I think a lot of pilots are thinking, okay, I've just bent metal on the plane, right? Let's say it's not an outright crash. I've just bent metal, and this plane is no longer airworthy. There's a big old bend in the wing, or part of the strut has been really damaged, and the plane's no longer airworthy. And they read the notification here, and they go down to option 6, and they're like, "Oh, what? I don't have to report that because it's damage to property other than aircraft, right? Other than the aircraft that exceeds 25,000. So unless you ran your plane into a $25,000 light pole or fence, then I don't have to report it, right?" Well, not exactly, right? Not exactly, because we're going to go back up to the definition section. So in the definition section, it says an aircraft accident. So an aircraft accident means an occurrence associated with the operation of an aircraft, which takes place between the time any person boards the aircraft with the intention of flight and have disembarked, and in which any person suffers death, serious injury, or in which the aircraft receives substantial damage. So an aircraft accident is defined as one of the definitions, all right? We can have people that die or have serious injury, and there's definitely definitions for both of those. Death is pretty easy to define, right? But serious injury, that's also defined in here. So the aircraft receives substantial damage. That is one of the things that constitutes an aircraft accident. So then we have to go down further and let's find substantial damage. It's right below the definition of serious injury, if you're interested in that. So serious injury, we'll just talk about it since I mentioned it here, requires hospitalization for more than 48 hours within 7 days that the injury was received, results in a fracture of any bone. There's other stuff in there. I'm not going to read all those out. So serious injury is an option, but we're just thinking about substantial damage. Okay, so now we've got substantial damage means damage or failure which adversely affects the structural strength, performance, or flight characteristics of the aircraft and which would normally require major repair or replacement of the affected component. Okay, that's substantial damage. They broke it down further to say engine failure or damage limited to an engine if only one engine fails or is damaged, bent fairings, cowlings, dented skin, small puncture holes in the skin fabric, ground damage, rotor propeller blades, and damage to landing gear, wheels, tires, flaps, engine accessories, brakes, wingtips are not considered substantial damage for the purpose of this part. Okay, so that's kind of a long definition. So what we have to do is we have to kind of put our thinking caps on and think about, all right, how badly is this aircraft damaged? And is it considered substantial in terms of the substantial damage definition in NTSB Part 830? That is the first question you have to ask. So let's say you come in and you have a really hard landing and the landing gear is kind of messed up, right? Well, this says damage to landing gear, wheels, and tires. That doesn't count. So if just my landing gear is damaged, that's not considered substantial damage. But if my landing gear got messed up and that wound up putting me off the prepared surface and I flipped over and I'm on the backside of the airplane and it bent the rudder, and now the rudder is, totally trashed, and maybe parts of my wings are also damaged, now that's considered substantial damage, okay? So if we go back down to the immediate notification, Part A says an aircraft accident. The first 3 words, an aircraft accident, requires immediate notification. And then an aircraft accident means that, among other things, the aircraft received substantial damage. Okay, so I don't mean to beat a dead horse here, but I've seen several pilots that I think misinterpreted this regulation and didn't think they needed to report something that they actually did need to report, right? Just because no one dies, just because the plane can be repaired, none of that means that, hey, I don't need to worry about notifying the FAA about this or the NTSB because, hey, we're all good and I'm just going to fix this airplane. I'll put it in the hangar. We're good to go. That's definitely a pressure, right? Because it's pretty intimidating having to report an accident, especially if you're the pilot of the accident aircraft. That can be pretty intimidating. All right, so let's say that unfortunately you get involved in an accident as defined per NTSB 830. So there's been substantial damage to the aircraft. First and foremost, if you or your passengers are injured, call 911. That's the first call, right? Hopefully I don't have to reiterate that, but that's the first call that you make. But let's just say hopefully that's not the case and you're fine, but the aircraft is pretty messed up, right? And it's definitely like you get out and, part of the wing's missing or something, or wing strut's gone, the tail's fallen off, something like that. And, okay, this is definitely substantial damage. What do I do? Okay, so for that, I'm going to post up this number here. And if you're on Discord, you can find this number. It's the Regional Command Center. So after you've made sure that everybody is okay, right? That's the first thing, is make sure everybody's okay. Extract everybody from the aircraft, right? You want to get them out of the aircraft, get back to the FBO, secure the aircraft as best you can, right? If there's stuff blowing around, you don't want to fight out the runway. You want to turn off the mags, turn off the fuel, get it cordoned off. You probably want to talk to an airport manager if it's at an airport and let them know, hey, you might want to file a NOTAM or something that we're closed temporarily while we get this sorted out. And pretty soon, you're going to want to make a phone call to the Regional Command Center. So the Regional Command Center is kind of the hotline that you call in case of an accident, and that's going to get the ball rolling on any investigative process, including those immediate actions. So generally speaking, the NTSB, so this number, if you want to write it down, it's 817-222-5006. And that's on the Discord server and posted in the live stream podcast companion. Anyway, that phone number, 817-222-5006, that will get the process started. So you tell them, hey, there's been an accident. Nobody's injured, but the plane is pretty messed up. What would you like me to do? And more than likely, they're going to say, okay, if nobody's injured, and let's say it's a small GA airplane, they're probably not going to dispatch somebody from the NTSB to investigate this. So they're going to want to get some pictures of the accident scene, the aircraft as is, right? If you have to move the aircraft around to extract people and secure it, that's fine, right? Safety is the number one thing here. Preserving people's health and life and eyesight and all that stuff, that takes priority. But we don't want to mess this accident scene up too much because we're going to use these pictures to do the investigation. So once you get those pictures, generally speaking, the NTSB is like, okay, those pictures are fine. Those work for us. Good job on taking those. You can now move that aircraft. And so you're going to want to work with people there at your airport. There's not a lot of people that are trained in moving crashed aircraft, so you gotta have to do the best you can. But you want to be careful here. There's a lot of different ways that you can injure yourself. There's a lot of ways that you can really damage the aircraft more, right? It might be repairable, and in moving the aircraft, you make it basically unrepairable. So I would highly suggest taking your time here, talking to an experienced AMT, like an AMP, an AMPIA, somebody with mechanic experience, so they can say, all right, it's good to pull the aircraft from here, or here's, get a plan of action together before you just go out there and drag it off of the infield or runway and just cause more damage, right? So we want to try to avoid that. But that first call, before we do any of that, needs to be the Regional Command Center. All right, NTSB, they also have a hotline. This is a national number, and that Regional Command Center, that'll work anywhere in the country. So you just call that, you tell them where you're at. It's kind of like Flight Service Station. They'll be able to get you to the correct person without any problems. Now, the NTSB national hotline is 844-373-9922. Now, that number I don't think you really need because the Regional Command Center is going to notify the NTSB, but that's the NTSB's number as well. Okay, so let's go take a look at this form here that I've got pulled up. This is, make sure that's actually pulled up. Yep, sure enough. Okay, this is the NTSB form 6120.1. So if you ever wondered, okay, well, what am I going to be requested? What type of information is going to be requested of me in the case of an accident? This is it right here. This form, the 6120.1, you can search that at home. Again, you can go to our Discord channel, and it's in the podcast companion. So there's a link to this PDF document. It's 10 pages long. On page 8, I think if we scroll down to page 8, it will Yeah, the page 8 is where we give the narrative of the flight. So we're gonna write down just the narrative of, hey, this is what happened. Here's what I think we should do to make it better, or have it not happen again. It even gives you an option to do that. So that's all the information that the NTSB is going to gather, and they'll do that in that initial investigative process. So they will send this form to the accident pilot, and of course, this is all happening in that 10-day time span. That's all going to be done probably within just 2 or 3 days of the accident, actually, that they'll send this out. And there's also an instructions for this form that they'll send you. So this is the 6120.1 instructions for the pilot or operator of the aircraft for the incident report. So you follow those instructions, you fill out the form, and you start the investigative process. All right, there's another advisory circular that I posted on here. This AC 150/5200/12C. It's a weird AC name as far as the number goes. This is in the Discord channel as well, but it is titled First Responders' Responsibility for Protecting Evidence at the Scene of an Aircraft Accident or Incident. So I just posted it out on here. There's some decent links in here as far as the different Fire Protection Association stuff. And honestly, there's a lot of stuff in here. It's not that long of an advisory circular, though. So if you are involved in the first responder world at all, this would be a good place to start of helping prepare for an aircraft accident at your local airport. Now, also, what I've got pulled up is, never mind, I don't have that pulled up anymore. What I had pulled up was an FAA safety team. So we talked about the WINGS program in a previous episode. Part of the WINGS program includes a safety seminar over first responders, which really pilots are probably the most common first responder to aircraft accidents at an airport because pilots are at the airport. Generally, it's not like the fire department. It's usually a pilot or a mechanic that's the first on scene at an airport. So I'm actually giving this seminar at my local airport here in the next couple of months, where we actually bring in first responders, the true first responders. We bring in the fire department, the police department, whoever might be responding to the airport, and we give this seminar to them, and we talk about, hey, here's the dangers that you could face with an aircraft that maybe is a little bit different than another vehicle. Here's how you enter in the aircraft premises, right? After 9/11, most of the airports are locked down with gates and locks, and so here's how to open up all of those. Here's where you would want a taxi to access the runway. Here's the frequencies and the types of radios that we're using. If you wanted to make a radio call that you were entering the aircraft or entering the airport environment on CTAF, if it was uncontrolled. If you're at a towered field, talking about the tower and ground frequencies. Of course, if you're at a towered field, a lot of this stuff is formalized, but non-towered fields, a lot of this isn't formalized at all. So it's really up to the FAA safety team at your local FSDO to make sure this coordination has happened beforehand. So it's a good reminder if you're involved in your regional FAST team and you haven't had one of these briefings in quite some time, I would get with your local non-towered airport and say, hey, let's do a first responders briefing and let's talk about what's going to happen if and when we have some sort of incident or accident here at the airport. All right, so those were the things I wanted to cover for an aircraft accident. Now we're going to move on and shift gears here. We're going to talk about avionics. So avionics, the reason I wanted to talk about this is I was doing a lot of CFII check rides. And in the process of doing CFII check ride, I was at a flight school and they were mainly using aircraft that had dual G5s and like a 650 or 430. The only analog instruments that they had the 3 pitot-static systems. So they had an airspeed altimeter and VSI. But everything else was pretty much digital, and including the G5s and the GPS. During the CFII check ride, the CFIIs, they start talking about all the guts of like the altimeter, the aneroid wafer, thing. That's such a fun thing to say, the aneroid wafer. I'm not sure I could build one or tell you how it even looks. I mean, I kind of conceptually know how that works. And I think we all, as instructors, know conceptually, here's how a solid state gyro works. Here's how a analog altimeter and airspeed gauge work. And we know the details of those baffling and needles, and look, they're like tiny little Rube Goldberg devices there that translate a physical force into a gauge that we can then read, right? It turns a physical force into a number that we can use. So after these CFIs started describing the guts of these instruments, I'm like, well, what about that G5? What does the inside of that G5 look like? And they were like, I don't know. None of them, they said, oh, it uses accelerometers. I was like, well, what's an accelerometer? I don't know. That's what my instructor told me to say, right? That's what we read in the book is just an accelerometer. And we're like, okay, well, that's an accelerometer. We don't think the same thing about an altimeter. We don't think, well, that's just an altimeter. Well, how's it work? Oh, well, we get into the aneroid wafer discussion, right? So we know how the guts of these analog instruments work. And my point is, we don't know how the guts of that digital instrument work. So I'll probably be doing a longer podcast on this because I have to get smart on it myself. And, let's talk about that for a second. I'm not going to fail you on a check ride because you don't know what some of the stuff I'm about to talk about is. That's not the point. The point of what I'm discussing here is just to make us all smarter, right? It's just I notice there's a gap in knowledge. And so I'm just trying to bridge that gap here and fix it because I think we've done analog instruments for a very long time. Digital instruments are kind of new, and our training process hasn't really caught up with that. So if we're going to learn the why behind these instruments, which I think is valuable, then we need to start somewhere. But I want to carefully caveat that with I'm not saying that you need to spend hours and hours and hours digging into how these sensors work that we're fixing to talk about. I don't know that having detailed knowledge of how an accelerometer, a solid-state accelerometer, and basically a MEMS sensor, which we're fixing to talk about, I don't think having detailed knowledge of that makes you a safe pilot necessarily. But I think seeking that knowledge, that depth of knowledge of your systems, I think it's valuable. So what is an accelerometer? An accelerometer it's using MEMS. Now, MEMS is an acronym. Of course, it's an acronym, right? We just needed one more acronym. Anyway, the MEMS stands for Micro Electromechanical System, MEMS. I'm actually glad that that's an acronym because that's a mouthful to say. So these things are tiny. I've got this website I pulled up from Joule Instruments. I'm not sure what they make, but they looks like they some engineer MEMS. And these things are microscopic devices, right? They're 0.001 to 0.1 millimeters. They're very, very small. And what it is let's just watch this video here. This is a MEMS accelerometer. And make sure I give it proper credit. This is, well, you'll see. I'm playing his YouTube channel here. Evil Monkeys Design. That's who did this video.
Today we're going to take a look at a yaw rate sensor from inside of a Subaru vehicle. There's a few interesting components inside this module, but the one we're going to take a look at today is this MEMS accelerometer. It's pretty easy to get inside because the lid is held on with just these little bits of plastic. There are actually two chips inside, one that does the actual sensing and the other one that processes the sensing data. The smaller of the two is the MEMS accelerometer and was actually surprisingly hard to get into. Inside are two sensing elements in different orientations, which consists of a large free-floating mass surrounded by fixed combs. Any movement in the mass results in...
Okay, so I'll pause it right there. Hopefully this is working. But what he's done is he's taking this thing apart, and in the process of him taking this apart, this video is on our Discord channel, and it's just a quick, a YouTube short. But he's taking this thing apart, and it's very, very small. We're talking about, just a few millimeters wide, and in it, he's finally uncovered basically this free-floating mass, is what it's called, and it's on these tiny microscopic springs. And if you can imagine this mass with these springs, and we actually have a picture of it, kind of a picture of the circuitry here. But essentially, all it is if you can imagine this floating mass on springs, the whole unit moves, and the little floating mass, it has its own inertia, so it takes us a little bit longer to move, and you get kind of this little microscopic movement. And what that does is that changes the resistance of the surrounding metal. And so that's the whole point of MEMS and what we're going to talk about for digital avionics is it's using electronic or electrical resistance. So variable resistance is kind of the whole principle behind most of the things that we deal with that are digital. So the example I like to use is we pretty much all used a digital bathroom scale or a digital kitchen scale, right? Most people have come in contact with that, right? We don't use the big analog or, physical scales anymore that were really big, and even the older ones where you would have to put a known weight on one side and, put the amount you're trying to weigh on the other side, those balance scales. We don't have that. Maybe in some of the doctor's office, you have kind of the sliding metal scales. But most of the time, we just press a button and a digital number pops up. I'm curious type, so I'm like, well, how did it take my weight and translate it into a digital number and put it on an LED screen? Like, how in the world did it do that? And the answer is variable resistance. And so it probably has, or it has some sort of component that's very, very small that changes its electrical resistance at a known rate when a physical force is applied to it, right? That's how this basic variable resistance works. So the way the MEMS sensor works for an accelerometer is these things that are kind of moving around in the MEMS unit itself. They're changing the resistance at a known rate of the metal around them, and we're able to map that out and turn that into a number. So when the aircraft turns, it shakes these little plates enough, and calculations happen. The resistance is known, and it spits out an airspeed, or it spits out a heading, a track. Now, the airspeed, they're using different variable resistance, but it's also a MEMS unit. So it's probably like a strain gauge. And a strain gauge is something that if I bend a metal, I change its resistive properties at a known rate. There's other stuff like a piezoelectric principle, where I have a piezoelectric crystal that when I apply force to that crystal, or maybe a ceramic or metal or something like that, it changes the resistance, and I can measure the resistance that's going in and leaving, and that gives me a known amount that force was applied there. So I can turn that into digital information on avionics. What these devices are doing is they're using microscopic components of a solid state microchip, and this has been in the news a lot, right? We talk about, hey, we all need microchips, right? That's a big thing of national security and just consumer goods, is all these microchips. Well, these two videos, I think they show the feat of engineering it takes to develop these chips. They're doing a lot more. I mean, yeah, they're processing stuff, but the tiny, tiny scale that's taking place here and they can detect the magnetic field of the Earth and give us our heading. All right, so let's look at this video here, because this is the next one. This is a TMR, which is tunneling magnoresistance. I don't even know if I'm saying that right, but let's take a look at this. And this is this is from Kodo Technology.
Show you to give them some demonstrations of our TMR sensors. But before I do, I just want to give a quick overview of what exactly is tunnel magnetoresistance. Well, the device itself is actually formed by two ferromagnetic layers sandwiched between a very thin insulating layer that's only about 8 atoms thick.
Okay, I just wanted to pause it there. They're layering stuff between stuff that is like 8 atoms thick. So they can, like, that's just incredible to me that they can even do this. It's like magic. But I'm going to skip forward here to where he actually shows how small this thing is.
Right here, when I have my little magnet here approaching, as that magnetic field gets stronger, it's responding.
All right, so he's holding the device in one hand, and he has a tiny magnet in the other hand, and you can see that one end of the magnet is it's coded as north, so it's north polarized, and the device in his hand is about the size of the inside, the very palm of his hand, maybe 1 inch, 2 inches in diameter. But the device at the very end is like smaller than a housefly. It is tiny. The sensor is incredibly small. And so you'll see as the field moves in, As he moves that field closer to that device, you see a green bar appear on the device. And so that TMR little tiny little device, 8 atoms thick sandwich, just incredibly small, is able to detect that North Pole magnet and just has a visual sensor off. So I'm sure this is just a demo unit, but you can see the usefulness of this, right? If we had this mounted on an aircraft and it was sufficiently sensitive enough that it can detect the Earth's magnetic field, then you could easily program, instead of having it show those lights there, you could program it to change a digital unit to show a change of heading. So this is how a solid state AHAR system would work. And this, again, the size, I just can't reiterate how tiny these things are. So the NIMS and this TMR unit, those are the guts of a basic G5. So Garmin, of course, the other unfortunate thing here, and it's not necessarily unfortunate, I guess, but one of the reasons why we don't know what's inside of a G5 or what's inside of a G1000 is that's all proprietary. Garmin's not going to open up their engineering data and say, hey, here's exactly how we built this, because one of their competitors could come in and build it exactly that way. So the reason, the FAA just looks at the box and its performance. And if it can meet FAA standards, and the FAA probably does know what's inside of these, but again, the FAA is not going to release that to the public to, so everybody else could copy it in theory. But anyway, that's one of the reasons why we don't know what's inside of these Garmin units, is because it's all proprietary. But I guarantee you, it's something like that TMR unit and a MEMS unit. So you can take a look at both those videos, maybe go down a rabbit trail. And here's the challenge: is get to know how those, basic, microprocessors work of a digital avionics unit. And let's start teaching that in addition to how the guts of an analog system work. Because if you show up to a check ride and you know exactly what an analog wafer is and all that stuff, and I'll look at the cockpit and it's entirely glass, I'm like, well, you know how those analog instruments work. Well, how about these? And again, I don't think you need to give some sort of dissertation on how MEMS and magnetoresistance works. I don't think that's necessary at all. But just knowing that, hey, there are these microprocessor units that can detect movement, and they translate it with variable resistance into, a digital format that we can then program to show a number. That's how it's working. All right. So we've finished up with avionics. Maybe that will garner some questions we can talk about in the question and answer time. We talked about that. Now we're going to move on to maintenance and required equipment. So I was listening to a live stream on Saturday. Every Saturday there's a CFI boot camp, and this is a plug for them. If you are training to be a CFI, or if you're doing even commercial, thinking about being a CFI, any pilot really can learn from these. But if you just Google search CFI boot camp, they have a CFI power hour every Saturday. And this is Mike Shiflett is his name, and he puts on a great show. And he's got a great PowerPoint presentation that he goes through, and it lasts about 3 hours long. I mean, you can spend most of your afternoon on Saturday learning this stuff. And he opens it up for question and answers similar to this, but he does a much better job than I do. He's very organized. But he doesn't shoot those out in podcast format, so you can only participate live. And then there's a way that if you pay for his CFI bootcamp, you can get access to the backlogs. But anyway, he kind of inspired me with his discussion this past weekend to talk about maintenance and required equipment. But one thing that I found is, I'll pull up this picture here. And John, for this, I'll just, for editing purpose, I'll be talking about the pyramid that I have in that. So I'm not using the screen share right now. I'll jump back over to that though. So there was a picture of essentially a pyramid of airworthiness. And this is kind of how I've talked about it before, where the foundation of airworthiness is kind of 91213 or 91205, or the tomato flames mnemonic. That tomato flames mnemonic, I've talked about it before. I don't love it. It's a good way to memorize things, but remember, rote memorization is such a basic level of understanding, and it's typically more complicated than that. So I would much rather hear somebody say 91205. All right, but but it's way more complicated than that, right? If we gathered up all the stuff in tomato flames or grab card, if we put all those together, we wouldn't have a flying airplane. We would just have a box of parts there, right? It wouldn't be airworthy. And so you can have some interesting conversations with, well, what if our rudder is missing, right? What if the rudder's not in 91205? So if it's missing, could technically I still go fly because my plane doesn't have an MEL or a KOEL, and even if it did, the rudder probably wouldn't be listed on the MEL or KOEL. It's not listed in the 91205 section, right? So I could just go fly without a rudder, right? And the answer is, well, of course not. No, that's not going to happen. But this pyramid here, I think, is pretty good because it talks about the basic thing is your type certificate data sheet. So if you're flying an aircraft, it has a TCDS. I've talked about that before. It'd behoove you to know what your aircraft's type certificate data sheet looks like. I would have that pulled up when you're studying for your check ride as far as airworthiness goes and take a look at it. It's specific to your make and model, even your year, and you can see, the deflection of the flight control surfaces are listed there. Your static RPM, we were talking about that in a couple of episodes ago. All that's listed in your TCDS. So that's kind of your foundational document. And then you go up to required instruments and equipment. So that's your aviate, your annual has to be done, your VOR, 100-hour, altimeter, pitot-static, your transponder, ELT. Those things have to be tested and inspected appropriately, right? And then we get up to were our required inspections. Then we get to our required equipment. That's our 91205, and that's our day VFR, our VFR at night, and then our IFR. So those can all be found in 91205. And then the step up above that is then we go to our MEL. Our MEL, if we don't have an MEL, we're just going to go to 91213. If we do have an MEL, we still go to 91213, but we also reference our MEL first. And then there's the KOEL. That's our kinds of operating equipment list. We need to reference that. And then up above that are airworthiness directives. Those are outlined in 91417. And then at the very top, we use our judgment, 91.7. So the pilot 91.7 is the pilot in command of a civil aircraft is responsible for determining whether that aircraft is in a condition for safe flight. So if the rudder is missing, you use your judgment and say, no, it's not airworthy anymore. Right? It doesn't have a rudder. But the truth behind it is you're not even relying on just your judgment of knowing that the rudder is required. Because at the very base of this is your type certificate data sheet. So back to that, your type certificate data sheet says the aircraft was certified, and what that means is when the FAA inspected and certified, stamped that aircraft as being, the certification for that aircraft, it was how it was when it came off the factory floor. So the way I think about airworthiness, if something about that aircraft is different than when it came off the factory floor, then I need to have some sort of documentation proving that it's still airworthy, right? That's the way to think about airworthiness, is everything has to operate unless I can prove I can safely operate it without it. And I think we can have discussions where we can run into instances where people's like, yeah, it's fine. The plane's airworthy because that part right there, that doesn't really matter. Well, no, the burden of proof is on you to tell me why that part doesn't matter and why we can fly with it in that condition. So this kind of the genesis of this discussion here, I'm going to pull up a website again. The genesis of this discussion was aircraft damage. So I think most instructors have a pretty good handle on if they go out and a component is inoperative, they know the process, which is outlined in Advisory Circular 9167A, right? 9167A. In fact, I'll pull up the ACE guide here for a second because that's definitely in the ACE guide. So if we look at 9167A, we are conducting operations without an MEL. So that's in Chapter 4 of this advisory circular. And in Chapter 4, it gives us this decision sequence. And so page 4-4 of that advisory circular, it gives us a decision sequence of, hey, we go out and there's an inoperative piece of equipment. What do we do? And it takes us through this whole decision sequence. The last part of that sequence is do a safety risk analysis, which is on page 4-3. And that risk analysis includes, hey, adverse weather, night operations, diversion, crew fatigue, other human factor considerations. All those could play into you deciding that maybe something, if you're well rested and it's VFR in daytime and the weather's great, I would be comfortable taking that. But it's night, I'm tired, and we might have to go to our alternate and it's IFR. Now I'm no longer good taking that in operative equipment. So that 9167A is a must-read advisory circular. That's why I included it in the ACE guide. But let's go back to the maintenance manual, because this is something that's new. If you're a CFI, I bet there's a lot of CFIs that's never even looked at a maintenance manual before for an aircraft. So I've got the 172 maintenance manual pulled up, and I found this online. You can purchase, current 172 manuals, but I didn't do that. I just have one that I found online here. And I'm on page 18-4. And the reason I pulled this up is because this is a fuselage section, and it defines the fuselage. But then the first thing it talks about is negligible damage. So it actually has a definition in the maintenance manual of what negligible damage is. Now, the Cessna had this maintenance manual approved by the FAA. So as long as this maintenance manual says that the damage is negligible, then you're good to go. So if you go out to the airplane and you see a dent in that airplane, and the maintenance person, the AMT, says, "Oh, you're good to go on that." This is how they're making that decision, or this is how they should make that decision, is they've gone into the maintenance manual, they found the definition of negligible damage for that control surface or that surface, and they've said, "Hey, we can basically not fix this. This is okay. This is just minor damage. It's not going to affect the airplane in any way." But what this maintenance manual will do is it'll say, hey, if you can cover it, if you can patch it with like a 2-inch in diameter piece of metal or fabric, then that's considered negligible, and it's not a major damage, and it's not going to drive a major repair, which would require a Form 337. So the whole gist of this was to say, hey, there's this whole other document that you may or may not know about. That's the aircraft maintenance manual for the aircraft that you're flying, and it gets approved just like the aircraft does as well. So one of the things that's in here that I thought was interesting is it has, for the Cessna anyway, in section 3, it talks about the fuselage, and in the first section, it talks about the windshield. And I've actually came across this as I went up to a windshield, and it had holes drilled in the windshield. And this was on a check ride, right? They had holes drilled in the windshield. And of course, I see it on the check ride pre-flight, and the pilot tells me, no, that's an improved fix for the Cessna windshield. I was like, well, that's interesting. I've never seen a windshield that had holes drilled in it, and as a fix. So I did a little bit of investigation, and I had a Cessna maintenance manual here. So I scroll down, and sure enough, in the section here, 3-2. When a crack appears, drill a hole at the end of the crack to prevent further spreading. The hole should be approximately 1/8 inch in diameter, depending on length of crack, thickness of material. Temporary repairs to flat surfaces can be accomplished, and it lists that there. And then if you scroll on down here, it says this type of repair is used as a temporary measure only, and only's in caps, all caps. And as soon as facilities are available, panel should be replaced. Okay, so that pilot in that case was partially right? They were right in that was a approved repair. But what they were wrong about was that does not mean that we can just indefinitely fly around with a cracked windshield that we just did a stop drill fix on. The point was to get us home, right? We drill the holes in it, that gets us home. That's the point. And the maintenance manual said that. So that's an example of where the burden of proof is on that AMT to prove to me that repair makes the plane airworthy. And so the way the maintenance manual is written, it's pretty clear that that's not an approved permanent repair, right? That's an approved temporary repair only in order to get you home where you can go and replace that panel. Okay, so that is one of the manuals that you probably have never seen. Another manual that you probably have never seen are the Aviation Maintenance Technician Handbooks. So these are actually pretty interesting. I'm going to pull them up here. We're not. We're just going to look at the table of contents to see. But if you're a uber nerd like me for aviation and you just want to soak up as much information as possible, there is a lot of information in AMT manuals. And this one is the airframe. I think this is volume 1. So we've got 9 chapters in volume 1. We have 10 through, we've got 7 chapters in volume 2. And then that's the 31B, that's volume 2. And then we have the general handbook. And I believe there's around 17, 18 chapters in addition into these manuals. So these manuals have just a metric ton of information about how airplanes work. So if you're wanting to know about how an appropriate repair would be done, right? If you're out there looking at a flight school airplane and you're like, I'm just really not comfortable with how this thing is kind of taped together here, you can look at those AMT manuals, or you can look at the manual for the actual aircraft, and you can see, okay, what's the approved method for that? So that involve a little bit of word searching and stuff, but you should be able to use these manuals. And if you want those, they're on the FA site. They're also on the Discord link, of course. But if you're interested in those, they are the 8083-31A, the 31B, and the 30B. Those are the current aviation maintenance technician handbooks. All right, and last but not least on the aviation maintenance side, we have Advisory Circular 4313-1 Bravo, and that's acceptable methods, techniques, and practices of aircraft inspection and repair. And I think we probably have some AMTs that are on the Discord. I know we have AMTs on the Discord. So some of them are probably going to humble me and say, Seth, you're completely wrong about all this stuff, and that's fine. If you want to type in a correction, be like, hey, Seth, you're off base here, go for that. But I think pilots should know this information too. So this advisory circular is one of the longest ACs I've ever seen. It's 756 pages long. It's much longer than a lot of the FAA handbooks by itself. And this has all of the methods and techniques, kind of the general techniques, accepted techniques to repair aircraft and inspect aircraft. So if you're concerned about a plane that you're flying, or if you're concerned a plane that you own that maybe it came back from annual and there's something that looks a little weird there that you've never seen before, like, hey, that's an interesting way to repair. Is that in there? That you can kind of dig for yourself inside this advisory circular or in the AMT handbooks and find out, or in your aircraft's maintenance handbook, to see is that an approved repair or not. What should be going on here. But I'm really interested about maintenance stuff, so I probably nerd out on this stuff a little bit more than your average Joe. But I thought I'd put it out there because I was like, that's something that we don't ever really talk about, is the maintenance side and how much data is out there that it's free for the taking. All those manuals that I talked about, the advisory circular, that's all out there for you as a pilot to review. So I would encourage you doing that. All right, I've droned on. We've talked about MEMS, we've talked about NTSB and maintenance. So I've got a couple Discord questions here. Can MEMS-based sensors ever fail? And if so, what are their failure modes? So that is a great question. That's Proto Wilco from Discord. So that's one of the things that I love to talk about is let's talk about failure modes of MEMS, right? How can they fail? And the key takeaway on MEMS is they're very dependent on electric resistance, right? They're all using resistance. So when you're in an aircraft, and this is pretty intuitive, right? If you're in an aircraft that has a lot of digital avionics, you know that you're highly dependent on your electrical system. And so one of the failure modes that I really want to dig into is electrical failure. How many backups do I have? Do these have integral backups? Do I have an avionics backup? If I go to battery power, how much juice are these units using up? How long are they going to be active? Those are all things that I want to ask. I would also want to know, what are the backups here? And Garmin talks about that. Avionics talks about that. So you would want to get in the specific manuals on, hey, what are the failure modes here and what will they look like? And that's something that I'm personally going to try to get better at as I give check rides in more and more kind of glass aircraft, is we typically fail by just covering up. An analog instrument, you just cover up. Well, unfortunately, that's not how a real failure is going to happen. A real failure is going to have red X's, or it's going to have blank data or missing data. And so I think we need to do a better job as instructors, and I need to do a better job as an examiner of simulating what an actual failure is going to look like when it comes to those MEMS units. So that's a very good question to ask. All right. Definition of airworthy is in 14 CFR Part 3. Airworthy means an aircraft conforms to its type design and is in the condition for safe operation. Yeah, exactly right. It has to conform basically with how it came from the factory. That's how my simple Arkansas brain likes to talk about it. That plane has to be, if it's exactly like it came from the factory, then I'm good to go. If anything else has changed, it may not be airworthy, and that's going to lead me down different paths on determining if it is airworthy. All right, and then Frey, regarding avionics, I'm a CFI who worked in Garmin's aviation department. If you're interested in how Garmin makes avionics, some inside knowledge here. Garmin does give tours of the factory, and you can reach out to aviationtraining@garmin.com for more. I might do that, Frey. Thanks. That would be really interesting. Okay, those are our Discord questions. I'm sure we'll get more. John, what have we got?
All right. Just as a reminder to everyone on YouTube and Discord, of course, please leave your questions in the chat and I can ask them on the show for Seth, or feel free to join the Discord and you can raise your hand. I have opened up the ability for people to raise their hand in Discord. So if you want to speak live on the show, go ahead and do that. But a question for you, Seth, from YouTube. For the commercial pilot aeronautical experience of 61-129, Jared Banning has a CFI that gave him 20 hours of instruction in a BE-35, but due to insurance was not able to let him do the takeoffs or landings. Would this count for 61-129 experience? And he does have training in a technically advanced aircraft on the takeoffs and landings and ground reference maneuvers, but only about 5 hours in the TAA airplane.
Okay, so he got training. So what did the insurance have to do with that? Sorry.
The insurance wouldn't let him take off or land in the BE-35, which I'm assuming is a Beechcraft.
Oh, okay. It wouldn't let him take off or land. Well,
yeah, so it wouldn't let him take off or land, but he has 20 hours in that. And I guess he wants to know, basically, can the 5 hours of TAA airplane time where he did do the takeoffs and landings combine with the other thing to meet the necessary requirements of 61-127 and 129?
Yeah, so I've got the ECFR 61-129 pulled up here, and that's the 10 hours of complex airplane turbine or technically advanced of this section, or any combination thereof. So that's the key phrase there, or any combination thereof. So if he's got 5 hours in a complex, which sounds like, the BE-35 would count as complex, and he's got 5 hours in a TAA, and those are all endorsed properly, right? We've talked about that. Make sure your instructors are writing in the comments that training was done to 61-129 standards, and that's probably what you should put in the remarks, is just IAW in accordance with 61-129. So as long as that's there, there's nothing that says it has to be, you have to take off and land. That's an odd restriction for insurance. But it probably was, a BE-35, that's a bonanza. So they can be relatively expensive to insure. So they're like, hey, we don't want you going out there and doing takeoff and landing training. So I can see how that works. But yeah, you should be able to use that. Just make sure it's logged correctly.
So Will Johnson is flying out of a Class Delta, and at this airport, it's common to switch to ground after landing and clearing the runway, even if the tower doesn't tell them to switch frequencies. And he wants to know, is that technically allowed?
Yeah, I've done that before for sure. I hate saying, yeah, that's okay without being able to point to the exact reference of why that is okay. But unless the tower, and it's probably in the pilot controller handbook. So if we have a controller, I know there's a controller that's on the Discord. I don't know if they're with us tonight. But my understanding of it is, unless the controller says, stay with me when you clear the runway, I'm switching to ground. Because a lot of times the tower controller is pretty busy giving other clearances and stuff. So I clear the runway, and if I'll wait for them to hand me off, especially at a really busy airport. But if it's like a basic class Charlie and they're busy, I'll just switch over to ground. I'll say, hey, ground, I'm clear at Bravo, ready to taxi to Atlantic or whatever. But if they tell me, hey, November 1, 2, 3, 4, clear at Bravo, stay with me to park. Okay, well, I'm going to stay with Tower because a lot of times it's a combined frequency. So if that's your common practice there, then I don't think you're hurting anything. That's definitely not something, if you did that on the check ride, it's not like I would fail you for switching to ground, but before Tower told you to switch to ground, because that's not a big safety concern. You're going from one controller to another, and if ground didn't want you there, they'd be like, hey, what are you doing here? Go back to Tower. Okay, lesson learned, not a big deal. So yeah, I wouldn't worry about that. We've got a couple asking to speak. I'm going to bring Jared Banning on. So Jared, the floor is yours if you want to ask your question.
Hello, sir. Can you hear me?
I can.
Awesome. No, thank you very much for answering. I'm just the guy that answered the YouTube question about the 61-129 complex time. It is just like you said. It was insurance requirements, super expensive for him, so he had to do the takeoffs and landings. But everything else was like you said there. It was for the commercial, portion. So just IAW 129. And then he did write me an actual endorsement with that, just stating specifically no takeoffs and landings, but you don't see any potential issue with that, a DPE, turning up their nose to it type of thing.
No, I mean, they may turn their nose up to it. They may raise an eyebrow, but I don't think there's any basis to say that time doesn't count.
Awesome. No, I appreciate it. Thank you very much. Do you have one other quick little question? It was about the commercial cross-country night and day. I did log that specifically, separate lines, 2 hours, daytime, and then we did the flight back at night. Question for you. We did do it with simulated instrument time. There was nothing in the regulations we found that would be counter to that, to do it under the hood for part of it. Do you see any issues with that? Am I missing anything? I had a CFI that told me it had to be VFR, but I'm not seeing anything in the regulations in 61-129 or 127 that say anything about simulated instrument time or anything like that. Can't be.
No, I don't believe there's restriction on that. I'm certain of it, but I'm trying to find the legal interpretation. I think there's a LOI about logging instrument time during the commercial maneuvers.
While Seth finds that, I would just say, regarding the first question, just make sure that time in the BE-35 was not logged as cross-country, which you cannot legally log if you did not both do the takeoff and the landing. So just make sure none of that time is cross-country.
No, we definitely did that. I did log some of them were longer flights with the point-to-point 50 nautical miles, but that is just for ATP, but I did not include that in my actual cross-country time or any logbook like that. I have a separate column in my logbook for those type of things. So thank you. Thanks for the heads up on that, OS.
Yeah, that's a really good point there, John. And now would be a good time, John. I guess you've sort of introduced yourself, but you can introduce yourself. I did it at the beginning of the show last week, and this week I did it.
It's a different spot every time. Usually it's like I think the first two was like right when you started the question and answer segment. Last one was right at the beginning, and this time we're halfway through the question and answer segment.
Yeah, I'm consistently
anyway,
inconsistent.
Yeah, that's fair. Keeps me on my toes. But anyway, I'm John. I'm a CFI in Massachusetts and Rhode Island. I'm also a FAST team representative. So if you have any questions about anything, you can find me in the Discord. I'm always there answering questions.
Yeah, I couldn't do it without you, John. I really appreciate it. Okay, we've got Chris on board, and Chris said that he's got the answer for switching to ground. So Chris, tell us.
Yeah, so my background is my previous job, I was actually an air traffic controller. And the answer is technically by the book, no, you cannot switch to ground. And I'll give you kind of the regulatory background and then the reference in the AIM, and then kind of my take. Regulatory and all the air class types that tells you have to make contact and then monitor on the appropriate frequency. Under IFR, you have to maintain a watch on the appropriate frequency, and you can't deviate from that without ATC approval. In the AIM section 4314, subparagraph C, basically it says a pilot who has landed should not change from the tower frequency to ground control until directed to do so by the controller. But the practical answer is, if that's what your airport's doing and that's the general expected behavior, I don't know any controller that will yell at you like 90% of the time.
Okay. Well, hey, I appreciate that reference. That's really good to know. I probably knew that at one point, and so I'll file that away. But yeah, thanks for that. I appreciate it.
No problem.
All right. See, I messed up. When I switch over to ground, when I think I'm being helpful, I'm actually breaking the rules. Don't need to do that. Do we have
Don't worry.
another?
I had another situation relatively recently that I found out that my being helpful was not actually helpful, and it was doing very much so the
Yeah.
opposite thing. So,
I guess we can talk about your topics you brought up earlier today, which I thought is interesting. Is, let's say you're doing a practice instrument approach. So if I understand this right here, John, that you're doing a practice instrument approach in VFR conditions, does that mean that you're allowed to do the published missed approach? So you talked about this on a FAST team representative meeting today?
yes, that's correct. So I guess the scenario is specific to, it's not necessarily specific to this airport, but the specific scenario was at Norwood, which is a class or class Delta underneath the Boston Bravo shelf. The missed approach for the ILS requires that you climb up to 3,000 feet. But 3,000 feet is also the altitude at which the Bravo's shelf begins. So doing that approach puts you inside the Bravo. And so the question was, does doing a practice approach in VFR conditions, right? You're on VFR flight following, does that actually authorize you when you receive your practice approach clearance? Because you do get a clearance when you're doing a practice approach, right? They're providing you separation. Does that
Right.
clearance imply that you are able to fly the missed approach at the published altitudes for that missed approach? And so there's actually a reference in the AIM that says that is not the case, and that a VFR practice approach does not authorize you by itself to do the missed approach in any capacity. You have to actually receive a separate, explicit instruction saying that you are cleared to do that.
Interesting. Okay. So basically you need permission to do, if you're planning on doing a published missed, you want to do that coordination before you just start on the published missed.
Yes, if you say that you want to go missed and you're just doing like a low approach, right? And they don't give you authorization to do the published missed, you can't do the published missed without that authorization, right? Particularly, I mean, again, if you're VFR, like you can probably follow the lateral path and that kind of thing. But the big idea is that it doesn't give you authorization into airspace that requires clearance or two-way radio communications or those kinds of things. So just be careful
Yeah.
with that.
All right. Well, I thought that was interesting. I'm glad you brought that up, because I don't deal with it a lot here in Arkansas because we just don't have a lot of I don't do most of my instrument check rides under radar control. We're in like non-radar environment. But that does come up during like I give a lot of check rides in Pensacola and Dallas. But in each one of those, whenever the controller is giving me permission to do that approach, they're telling me, hey, on your missed approach, fly heading 260, or if they'll ask, and if you're going to enter the pattern, they'll just you enter the pattern there. So I've never really had that come up, but I could definitely see how that could get a little confusing if I'm like out on a check ride and we get to the missed approach point and they haven't given us any clearance. What do we do now? And I guess the answer is ask for clarification.
In the specific scenario that it happened with the CFI, because this happened in real life with somebody, in that scenario, the controller was saying things slightly non-standard, like they forgot the whole maintain VFR thing in their radio call. So it was like slightly non-standard. I'm guessing the controller, messed it up, forgot it. Maybe they're newer. I don't know. But yeah, this was like the instructor decided to not go to 3,000 feet, even though that was the published missed. And it's a good thing that they did, because they found out after the fact. The specific reference, by the way, is AIM 4-3-22 Echo, for those who want to actually see it.
Okay, perfect. Yeah, and Chris he's the MVP today. So we'll talk about Chris's MEMS failure up here as well, point that he brought up. But he also said, just to clarify, we are discussing VFR practice approaches. We're not discussing approaches you do while IFR. Because even if you're practicing approaches, if you're on an IFR flight plan, you're still IFR. So those aren't technically practice approaches. They're real approaches. So most of the time when you're out there doing practice approaches, it means that you're on a VFR, you're not on an IFR flight plan, and you're just maintaining VFR. So that's important to know, because the controller may ask you to do things that they wouldn't ask you to do if you were IFR. So if you want the real IFR experience, file IFR flight plan and do approaches there. That's a really good opportunity for that is on your long cross country for your instrument training. That's why they want you to be on an IFR flight plan. And then those approaches aren't practice approaches, they're real approaches. And then the other thing Chris brought up is back to the MEMS failures. And I kind of talked about this, but he said a MEMS failure would likely result in the AHRS excluding that data, and so that's where the red X's come up. And so what I'm trying to do now is get a good kind of best practices on how to simulate a real-world failure where you wouldn't cover the instrument up. There would have data that's missing or have like a red X and say, hey, we don't know about this altimeter anymore. We're just going to pull it out of the data and you're not going to see altitude information anymore. But then he also talked about how inappropriate voltage to the chip would result in erroneous data. So remember, we were talking about the whole principle behind these MEMS units is they're using electrical resistance. And so if you have the wrong resistance somewhere, a bad ground, an overvoltage condition in your electrical system, and it's sending the improper voltage into that unit, then that could cause altitude fluctuations or heading changes or something like that. So yeah, we definitely have some weird things happen with the MEMS stuff. Thanks for that, Chris. All right, a couple other minor questions in YouTube I pulled up here. I'll just answer. See, you got a couple of those. And Waffles43 asked, do you have to be a 2-year CFI to give a FOI endorsement? And that is a good question. The FOI endorsement is kind of a new thing, so I don't have this memorized. Does anybody in the Discord here know for sure if that has to be a 2-year? I don't know. I don't think so.
Yeah, I don't think so either. So I think it has to be. The regulations are gonna say something to the effect of it requires an authorized instructor. Well, what's an authorized instructor for an FOI? Well, it could be an AGI, right?
Yeah, because the 2-year CFI is very specific to the initial CFI, right? It's not required for a ground instructor, and that verbiage is not used there. You don't even have to be a pilot to be a ground instructor. So you have to do the FOI in theory to get your AGI or instrument. So yeah, I don't think you need that that doesn't have to be a 2-year. And then Tyler asked, can an AGI sign us off to retest of a FOI? I think so. I think an AGI can sign you off. Again, that's a question. I think so.
Yeah, you can. Yeah, as long as the AGI, I believe, has to be an authorized AGI. It's one of those things where it's 40 hours, dual ground instruction given, basically, essentially, and I think 2 years also, actually. So yes, you have to be an authorized AGI to be able to provide initial CFI ground training and endorsements on the ground side of the house.
Yeah, on the ground, but on the FOI, again, I don't think that counts as like an initial CFI for just the FOI written.
From what I can see, no, any instructor or AGI could do it.
That'd be a good one. So I'm going to use this podcast companion, and I'm going to make a follow-ups FOI endorsement rules. Maybe that's how we can use the podcast companion channel. Is I'll put any follow-ups here because I don't want this to drag on for like 3 hours looking up every reference, and I don't have everything memorized at all. So that's one of the follow-ups. I think that'd be good to actually be able to point to in the FARs and say, yes, affirmatively, we can say that a FOI sign-off can be done by AGI, and that it doesn't have to be a 2-year. I'm pretty confident in that answer, but I don't have the exact verbiage pulled up. Oh, Adam G wants to speak. Adam, you're the last guy. I'll pull you up.
Hey guys, I just have a super quick question on just specifically on the topic of written exams. So I have a student who is considering retaking a private pilot knowledge test. I think he got a 75, so he didn't fail the first one. We've already reviewed his kind of deficiency codes, And I was thinking about it, and I don't know for certain, like if he retakes it, let's say he retakes the test and he gets like 100% or something like that, or at 95%, so like I would go back over you'd be required to review the deficiency codes for the retest as well. But for the purposes of the check ride, does the examiner like do they go off the codes for both attempts, or does it matter, or do they sort of, do you have any idea, like is there any kind of reason to retake the test, I guess is what I'm asking, to get a higher score?
Yeah. So the first part of your question, no, we won't review subsequent tests. We'll review the most recent test. So the same thing can be said if you fail it the first time and then you go retake and pass it. I don't have to see the failed, I don't have to test you on the items that you failed for and the one you retested on. It's just the retest error codes. So that's to answer your first question. I'm just using the most recent exam. The second question as to is that beneficial, I would say marginally so, because if you show up and you've missed 0 questions on the written, then in theory the oral should go a little bit faster because that's less stuff that I have to ask. In reality, I don't know that it makes a huge difference because there's a lot of stuff that we wind up talking about regardless of what how you did on the test. I will say that, the lower, if it's a barely passing score, it may be worth taking it again because that is one of the few things that I see about the applicant before the test begins, is I see their test score. And, we all try to be unbiased, and I totally get that some people are terrible at taking tests, and I'm one of those people. I'm not a good test taker, so it's not like I'm judging you when you walk in and you've got a 75. However, if you walk in with 100%, you get the same applicant, carbon copy applicants, one made a 75, one made 100. I think most of the time there's something in your back of your mind like, hey, I need to really check this guy that made a 75 because they made a 75, and especially if I look at the test report and it's like, hey, you made a 75 and this is your 5th attempt, I need to spend some time, going over this in the oral. But if you made 100% on your first attempt, I want to be careful. The other thing, I don't want to just gloss over things and just assume you know everything because you did well on a test, because this is just a test. But, it's kind of like wearing a collared shirt to the check ride. Does it help? I don't know. It probably didn't hurt, So, okay. Well, thank you for joining us for the VSL Aviation Podcast. Another week of this. I really appreciate it. It's really great to see people's comments on the YouTube videos. So you leave a comment. I try to answer as many of those as I can. Join us on Discord. Again, a lot of the information we talked about today is stored there on Discord. If you're listening to this on podcast format, give us a 5-star review. I'd really appreciate that on whatever podcast platform you're using. And then, of course, if you want to support the show, I don't have any donations or anything like that. I really just primarily do the ACE Guide. So go to our website, vsl.aero. Check out the ACE Guide, buy a purchase that. You can use code TRAVELAIR for 10% discount. And that goes a long way to supporting this content. But with all that being said, I really appreciate y'all, and I will see you next time. See ya.